All right, a ball is moving through still air, spinning clockwise about a horizontal axis through its center. Diagram shows the streamlines around the ball. So this is all laminar flow and all this stuff, right? The surface area of the ball. Now, when they say that, they mean the surface area as in like all the way around the ball, right? Surface area of a sphere is 4 pi r squared, right? Okay, is 2.5 times 10 to the minus 2 meters, right? 10 to the minus 2 square meters, right? That's what they're telling you. And this is, I think I've done this problem twice and gotten it wrong for the same reason twice, right? So estimate the magnitude of the force on the ball ignoring gravity, right? So the force is going to be ultimately whatever the difference in pressure is times the area is going to be the force. And this comes from, this comes from pressure is force divided by area, right? So force is pressure times area, okay? Now, when you use this area, you have to use the area as you see the ball, the frontal area, the cross-sectional area. This is really the cross-sectional area. Okay, and that is pi r squared, right? They told you what 4 pi r squared is, but you want to use pi r squared, right? So take that area and divide by 4. So take this thing, divide by 4, and then you'll have pi r squared, which is what you want to use, right? Now, how you find the difference in pressure, the difference in pressure from Bernoulli is going to be, well, you're going to go pressure 1 plus rho GH, 1 plus 1/2 rho V1 squared is pressure 2 plus rho GH2, right? Plus 1/2 rho V2 squared. Well, when you're looking at this thing, right, we're going to ignore difference in height because they don't really talk about it. And if they don't talk about it, we got to ignore it, right? Okay, what it's going to ultimately boil down to is that pressure 1 minus pressure 2 is going to equal 1/2 rho V2 squared minus 1/2 rho V1 squared, right? That's so you know you'll get good at looking at that. So this is going to be your difference in pressure, right? And you're going to put the density in there. Here's the density of the air. You're going to put the two different velocities in there. You're going to get a difference in pressure. If you get a minus sign, ignore it, right? And then you're going to go pressure times that area, which we already talked about how to get it, right? And then you're going to remember that slow air is high pressure, right? And fast air is low pressure. This is the Bernoulli principle, right? Slow air is high pressure. Okay, and then so you ought to be able to draw your arrow, which, by the way, interestingly enough, I drew my arrow the wrong way, which is kind of funny. So yeah, okay. Let's see. So let's see. The speed of the air is under the ball. So this is fast, right? This is fast. This is slow. So draw the arrow the correct way. Good enough.